Bismillahirrahmanirrahim. Greetings. This is going to be the third video lecture that I'm uploading about the concept of sequence and series. Now, in the previous lecture, we came up with the formula of n times n plus 1 over 2 for the series summation of 1 plus 2 plus 3 plus 4 and so on and so forth plus n, a finite, where n can be any natural number. In our example, the n was 100,000. So we knew that it's not practical to sit and add up to 100,000. What about this 100 million? So that came that because multiplication simplifies addition, so that gives us the idea that can be somehow change the multiplication, the addition of this 1 plus 2 plus 3 plus 4 and so on, plus n to multiplication. That was the motive. So because the problem that was given to us was from 1 to 100,000. So we took a smaller sample of that from 1 to 10, and we work on that to generalize it in a sense. And we noticed that from 1 to 10, the numbers, the sequence 1, 2, 3, 4, and so on and so forth, up to 10, comma, 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 they are kind of symmetric in a sense that if we take from 1 to 10 like a chain, piece, and then we take that chain. Think about improves your imagination. Take the chain to be kind of rigid. And then take that chain rigid from 1 to 10, having 10 pieces next to each other, welded together in a sense. And then the midpoint between 5 and 6 will be the midpoint from 1 to 10. And then rotate that one 180 degrees in a plane, or reflect it 180 degrees in a 3D. So that the last one, in this case is 10, lands under 1. And the next to 10, which is 9, lands under 2. And so on and so forth. And by doing that, we did succeed to change the addition into multiplication. And that led us to the formula of n times n plus 1 over 2. Fantastic, is it not? Now, the question is that can we do this one to other kind of series, to other kind of sequences, corresponding sequence? The answer is yes and no. Yes is for those kind of sequences that the difference between successive terms of that sequence remains same, is constant. Like the one that we just went 1, 2, 3, 4, the difference between them is always 1. Or 2, 4, 6, 8, 10, the difference between them is 2. Or let's say 1, 5, 9, 13, 17, that the difference between them remains to be 4. In those sequences, yes, we can apply the same procedure because there is a symmetry among them, and come up with a formula similar to n times n plus 1 over 2, or we can even modify n times n plus 1 over 2 to give us the sum of those kind of series. Now, those kind of series that they have these properties, or those kind of sequences that they have these properties that the difference between two successive terms remains same number, they are called arithmetic sequence or arithmetic series. and has his own class, and I will be uploading maybe 1 or 2 lectures about that one. Now, for this one, we came up and we said, okay, what about those that we cannot? Like, let's say 1 square plus 2 square plus 3 square plus 4 square plus plus n square. Well, n is any given natural number, or 1 cube plus 2 cube plus 3 cube plus n cube. Now, there is no symmetry between them. Try it. So we cannot approach the same of a rigid, as I said, rotate and 180 degree and align them and add and change addition into multiplication. We cannot do that. So then the question is, can we find some other ways that can give us a formula for, let's say, 1 square plus 2 square plus 3 square plus so on and so forth plus n square, where n can be any natural number, as I mentioned, like let's say 1 million square, which is a large number. We cannot sit and add. Can we come with some kind of formula? So the motive is that we try, because from what we do know, we are familiar, some examples, we use them to give us hint, to give us kind of clue, to start with problems that we do not know of. So we do know that 1 plus 2 plus 3 plus 4 and so on plus 1 plus n give us n times n plus 1 over 2 formula. We say, okay, can we get the same formula from some other way? That way that we use, that could also be used for 1 square plus 2 square plus 3 square plus so on and so forth plus n square, or 1 cube plus 2 cube plus 3 cube plus plus n cube, and so on and so forth. So the point is that the idea is as important as the first step of the discoveries. The idea is that to come with a function, that because with function goes input and output. The input of that function will be from the sequence of natural numbers, and the outcome of that will be the sequence of partial sum of each natural number. Now, with the domain and range of a function is a set, not sequence. But right now we are talking about sequence. But the natural numbers and the outcome of the partial sum is also natural number, and natural numbers form a set, so there is no contradiction. We can use the word set, even though we are dealing with sequence. In the first lecture, I did mention in detail the difference between sequence and set, so there is difference. But this sequence, they do honor, in a sense, they do respect the properties of the set. So we use the word set for them. So we are looking for such a function. Has input and output, we know what input is, we know what output is. And then when we found that function that gives us n times n plus 1 over 2 formula, we succeeded and we said, okay, can we use the same analogy, in a sense, to find the summation for 1 square plus 2 square plus 3 square and so on and so forth plus n square, or 1 cube plus 2 cube plus 3 cube plus n cube, or even 1 to the 4, 2 to the 4, 3 to the 4 plus n to the 4, or 1 to the n, 2 to the n, 3 to the n plus, and come up with formula for them. And that, again, the idea, the motive is to look for such a function. And that will be the lecture of coming lecture, possibly 2 more lectures about this. The topic will be this subject. Okay, then I thank you for watching, and as always, I wish you good health and prosperity, and I say so long. Oh, by the way, before I leave, always from now on, at the end, I have something here that I put up. I zoom it, I wait for a few seconds and I want you to read it carefully and take a note of it because it's very important. So let's see what that important is. So long.